Okie dokie, today is the day we learn integrals. I know I've been doing some practice problems, but I'm going to talk about that in a different video. So talk about integrals. So we find the derivative of a 4x to the fifth minus 3x to the third plus 7x plus 5. So I think of a derivative, you're going down in power, because we decrease the powers. The rule is we take u to the n minus 1, my goodness, u to the n minus 1, and we stick the n out in front, and if I do this one here, 5 times 4 is going to be 20, so we move the 5 down here, and then x to the fourth, because 5 minus 1 is 4. And if we do that, minus 9x squared plus 7. Here x would be to the 0, which is times 1, so we're good. But what if we want to go back up in power? That's where the up and down come from. Excuse me. How do we do that? So the rule's really simple. The rule is we take u to the n plus 1 over n plus 1. And there's one caveat, and that is that n cannot equal negative 1, because that would make our denominator 0, and then we have problems. So 20x to the fourth minus 9x squared plus 7. And so if we integrate this, we're going to take n plus 1. So I'm going to have 20x to the fifth, and then I'm going to divide by 5. Minus 9x to the third, because 2 plus 1 is 3, over 3. Once again, 2 plus 1 is 3. Then plus 7x to the first, divided by 1, it's still going to be 7. So then we do the division. This is going to be 4x to the fifth, minus 9x to the third, plus 7x. Now this is where we run into a problem slightly with integrals, in the fact that if there was a term here, we don't know it. And so since we don't know, we say plus c, an arbitrary constant number, because we lost the value of 5 here. We don't know that it's 5. So that's kind of basics of integrals, going back up in power. The rule is u to the n plus 1 divided by n plus 1, but n cannot equal negative 1. That's the way and this is called an anti-derivative, because we're going the opposite way we go when we take the derivative. I hope that was helpful.